Good morning, guys. Sorry I couldn't be with you today. One of my sons has strep throat, so you're getting virtual Mrs. McDonald for your 5-3 day 2 lesson today. Okay, fifth period, make sure you check the board with those values that we were finishing up yesterday and have those in your notes. Once you're ready, then we're going to continue where we left off. We've got one more definition for this section, and it's reference angles. So a lot of the formulas that we got yesterday, we looked at a picture in quadrant 1 to get it, but I mentioned that quadrant 2, 3, and 4, we would also see those triangles, and we had a couple examples of those. Reference angles are special because for any given angle, its reference angle will have the same trigonometric values with maybe a plus or minus sign difference because you're in a different quadrant. So the first thing we're going to talk about is how to find a reference angle. If you're in quadrant 1, the reference angle, which you see with the little prime, the little tick mark symbol, is the same as your original angle theta, so nothing to calculate. For the other three quadrants, quadrant 2, 3, and 4, your reference angle is just your angle that is the acute angle that gives you your distance to the x-axis. So you can see in quadrant 2, we have a rotation that's bigger than 90 degrees here, and my reference angle is over in quadrant 2 here, distance to the x-axis. In quadrant 3, my original angle rotates all the way past 180, and the reference angle is from that terminal side again to the x-axis. And then one more time in quadrant 4, we rotate all the way, almost all the way around to 360, and that remaining little bit is the theta prime that we're going to calculate. So we're going to draw pictures like this to help us find those reference angles on the next page. And we're going to do it with both degrees and radians like we usually do. So first we're going to start with 175 degrees. So we're going to begin by drawing that angle in standard position. So here's my axes. Remember, we're always going to start on the positive side of the x-axis, and then we're going to rotate because it's a positive angle counterclockwise almost 180 degrees. Okay, so that's my original theta, and that's 175. And our theta prime, get a different color here, is going to be that angle from that terminal side to the x-axis. So in this case, to calculate theta prime, it's just the difference between 180 degrees and our original angle, 175. So this one's one you can do in your head, and you're going to get theta prime is equal to 5 degrees. Okay, so let's see what this is going to look like with a radian. We talked about in a previous lesson that if you have a radian, one option if you get really stuck is you could always convert it to a degree and then convert it back to a radian in the end because that's where your answer is going to need to be in, but that is adding a couple extra steps. So hopefully you guys are getting used to where those values are at on the unit circle. 5 pi over 3 is going to be in quadrant 4. It's actually equal to 300 degrees. So it's this guy right here, approximately. There's my terminal side, there's my initial side, and that is my theta. So in this case, theta prime is again from that terminal side rotated to the x-axis, that acute angle. And you can see in this picture, theta and theta prime make a full circle. So we want to think about in radians, what's a full circle? Well, that would be 2 pi. So in this case, if I do 2 pi minus 5 pi over 3, and we can think of that with a common denominator. Instead of 2, I can write it as 6/3 minus, that's a 3 there, 5 pi over 3, and I get pi over 3 is my reference angle. Okay. Last but not least, we have 3.82. 3.82 is a radian. Sometimes people will look at that and say it's a degree, but it doesn't have our degree symbol. So what we want to do is think about our radians again. Remember radians, we've got a 0 over here, and then a half a rotation is a pi. A full rotation we just said was 2 pi. That pi on the left side you can think of like 3.14. So if I have 3.82, 3.82 is going to end up somewhere in quadrant 3. So my reference angle in this picture would be from that terminal side to the x-axis. There's my theta prime. Okay, that full rotation was 3.82. I'm actually going to label that. 3.82 was this guy. And it went past the x-axis, which was about 3.14. So you can see that theta prime, all I have to do is find the difference in those two numbers. This time I'm going to do 3.82. Theta prime, oops, that's a prime there. There we go. 3.82. Oh, my computer's being a little slow. Minus 3.14. And then you can just subtract that and you're going to get 0.68. And you can label it radians or you can just leave it like that would be our final answer. Okay, so that's how we find a reference angle. That's the very last thing we needed in order to be able to fill out our unit circle. So for your unit circle, you guys have a unit circle that I gave you in section 5.1. That unit circle already has all of the degrees and radians on it. So if you have that in your notebook, I would just take that out and use that for the rest of the lesson today. You can do this slide and then the rest of the slides on the front or the back of that paper, and everything would be in one spot. The sub also has a blank unit circle for you. So if you weren't here for 5.1 and you want to use that one, or if you just want to maybe take one of those and use it as like an extra unit circle to practice with when we get closer to your quiz, that's always an option as well. Okay, so let's talk about our unit circle. So what is a unit circle? A circle with radius 1 centered at the origin is called a unit circle. So we've got a picture here of just quadrant 1 from a unit circle. We've got some arbitrary points. We talked about these points yesterday. This point now is going to be on the circle. We'll call it XY, whatever that is. And then yesterday we talked about from a point, we always drop an altitude to the x-axis. The right angle is always going to be on the x-axis. We connect it to the origin. That's where our theta is going to be. And then we can label our sides. X is the horizontal, Y is the vertical. Remember from yesterday, those could be positive or negative. And then yesterday we called the hypotenuse R. Now we're going to say, well, we know the radius because it's a unit circle. The radius is 1, so we're going to give it a number. So now with this picture, we can calculate sine, cosine, and tangent. And you guys can be doing this just in the corner of your unit circle would be a great place to put this, or on the back of your unit circle. If I want to calculate sine for a unit circle, this isn't sine of any function, this is just on the unit circle. It's opposite over hypotenuse in this triangle, which is y over 1, which simplifies to y. So what does this tell us? It tells us any y coordinate on the unit circle actually represents the sine of the angle that we have to rotate to get to that point. Cosine is adjacent over hypotenuse, so x over 1, and that's just x. So what does this tell us? It tells us the x coordinate of any point on our unit circle is the cosine of the angle it takes to get to that point. And then tangent is y over x. That's opposite over adjacent. So we can take coordinates to calculate the tangent. And then what I don't have on here is our reciprocal functions, cosecant, secant, and cotangent, but we know that if we have these three, we can just take the reciprocals to get the other three. So I would write this quick little, I don't know, set of formulas in the corner of your unit circle. I think it's also helpful somewhere in the corner of your unit circle to write this point. The x coordinate, ooh, that's a terrible theta. Come on, computer. There we go. Is always the cosine, and the y is always the sine. So our x values are always cosine, and our y values are always sine. All right, so let's head to our big unit circle now. Hopefully you have yours in front of you already. I went ahead already and put all of these values that we had already filled out together in section 5.1 on here. If you need to pause the video right now, go ahead and do that. Make sure you have all your angles and radians, and then when you're ready, hit play again, and we're going to fill out coordinates next to each of these points. All right, so to get the coordinates of each of these points, remember our radius is equal to 1. So I'm going to start with the easiest points. These points are the ones that are on my axes. So right 1, up 1, left 1, and down 1. If I go right 1 unit on an axis, I end up at 1, 0. If I go up 1 unit, I end up at 0, 1. If I go left 1 unit, -1, 0. And if I go down 1 unit, 0, -1. So those ones are quick to get, just 1 unit in every direction. Then to get quadrant 1, and guys, when you eventually start using the unit circle, we're not going to memorize this whole thing. You're going to see once you have quadrant 1, you're going to be able to get everything else. So it's not really worth your time memorizing every single point, but quadrant 1 is going to give it away. So this is the most important part. All right, so we see these 35, 45, and 60-degree angles that we saw in our special triangles in section 5.2. And if you remember, we did all 6 trig functions for 30, 45, and 60. You could even superimpose in this triangle, in this circle, those 30, 60, 90 triangles here. Here's a 40, 40, 45, 45, 90 triangle, and then here's another 30, 60, 90 triangle in there. So you can see our 3 triangles in there appearing. If I want coordinates, I want the x and the y, which are ultimately going to be the cosine and the sine, respectively, that we found for 30, 45, and 60. So if you look back in your notes, that's where these numbers are coming from. We found together that the cosine of 30 degrees, the x coordinate, if we're at 30 degrees, is rad 3 over 2. And the sine, the y coordinate, is 1/2. And we use those ratios, x, 2x, and x rad 3 to find that, if you remember doing that with our hypotenuse. Okay, then for 45 degrees, we found that both the sine and the cosine were rad 2 over 2. And for 60, it was actually our 30, 60, 90 triangle, but our legs were flipped. So 1/2 and rad 3 over 2, and you've got quadrant 1. So again, if you're going to memorize quote unquote anything, you want to know these, and these are just coming from the ratios of your 30, 45, and 60-degree special triangles. Okay, then when we look at the other quadrants, you actually also have a 30, 60, 90. If I look at like 150, that's 30 degrees away from the x-axis, so that's a 30, 60, 90 triangle. 135 is 45 degrees from the x-axis, and 120 is 60 degrees from the x-axis. So the lengths of these sides of the triangles are going to be the same lengths that we see in quadrant 1. They're the same triangles. The only difference is, because I'm in quadrant 2, what's negative in quadrant 2? X coordinates are always negative in quadrant 2. So 150 is 30 degrees away from the x-axis. Its coordinates are going to match those of 30 degrees. Rad 3 over 2, 1/2. You can imagine, that's a 2 there, you can imagine just kind of reflecting that point over the y-axis is what we're doing, and then we just want to make sure in quadrant 2 our x is negative. For 135, we're 45 degrees away from the x-axis, so I'm going to reflect over my 45-degree point, rad 2 over 2, rad 2 over 2. Sorry, those numbers aren't any prettier. My computer's being a little jumpy from home. And my x is negative. And then finally 120, that's 60 degrees away from the x-axis. So I'm going to reflect that 60 degrees over, and that's 1/2 rad 3 over 2. Those same ratios, so 3 there. And then my x is negative. Okay, I'm going to go down to quadrant 4. Quadrant 4, we can take quadrant 1 and reflect it down. And again, we see those same triangles, those same ratios, except in quadrant 4, what's negative? My y's are negative. 330 is 30 degrees from the x-axis. So I use my 30-degree point, rad 3 over 2, and 1/2, but this time my y is negative. Let's make that look more like a 3. Oh, that's a terrible 3. Come on, computer, help me out here. Rad 3 over 2. There we go. 315 is 45 degrees away. So I use my 45-degree point, rad 2 over 2. And then my y will be a negative, rad 2 over 2. 300 is 60 degrees from the x-axis. Guys, notice everything is based off the x-axis when we're talking about this stuff. So 1/2 rad 3 over 2. And again, my y is negative. Okay, and then to get quadrant 3, you can just still keep thinking about how far am I from the x-axis. 210 is 30 degrees away from the x-axis, so we use that 30-degree point. Rad 3 over 2 does not like my 3's. Gotta write them really slow, I guess. There we go. 1/2, and in quadrant 3, we know both my x and my y are negative. 225 is 45 degrees away, so rad 2 over 2, rad 2 over 2, and both of them are negative because we're in quadrant 3. And then finally, 240 is 60 degrees away from the x-axis. 1/2, rad 3 over 2, and both are negative. All right, so you have a completed unit circle. So now let's talk about how we would use this circle. So let's say I wanted to know, I don't know, the cosine of 315. So if I wanted to know the cosine of 315, I'm going to find 315, and I know cosine is always the x coordinate on this circle. So my answer would be rad 2 over 2. Let's say I wanted to know the sine of 2 pi over 3. So I'm going to find 2 pi over 3. That's up in quadrant 2. I know sine is the y coordinate, and I get rad 3 over 2. Let's say we had some of those special ones we were looking at yesterday that weren't triangles, all the zeros, ones, and negative ones for those points that were on the axes. Let's say I wanted to know the secant of 270. Okay, so I look at 270. I just need to know that secant is the reciprocal of cosine, and cosine is my x-coordinate, 0. So what's the reciprocal of 0? 0 divided by something gives me 0. So if I flip that, I have a 0 in the denominator. It's undefined. So the secant of 270 is undefined. It's a reciprocal of 0. All right, let's say I wanted to know the tangent of 180. Okay, well, if I want the tangent of 180, I find 180, or pi, you know, whatever radian or degree you're given. And tangent on our unit circle is always y over x. So I can take my coordinates, 0 over -1, divide them, and I know the tangent of 180 is 0. So what this picture allows us to do is to find any of the 6 trig functions for any degree or radian measure that's in this picture. In addition to that, we talked about coterminal angles before, which this will be on the next slide, but coterminal angles are angles that they look the same, but they're a full rotation away from each other. So even angles that are bigger and smaller than this, you can add and subtract a full rotation to find where it is on the unit circle and therefore find the value of the trig function. On Monday, we're going to practice with some unit circle values more, and we're going to do it in a minute here. But we're also just going to talk about some ways that you can remember where the radians are at and what the points are. We've got some little tips and tricks, and I'll show you some different ways to do it that you can practice with your circle. Okay, so let's practice here. All right, find all of the exact values of the 6 trigonometric functions for 7 pi over 6. All right, so the first thing I want to do for 7 pi over 6 is I need to make sure I know what point that refers to. Okay, so this is where the unit circle is helpful. If I can get the point, I can get anything I want. 7 pi over 6 is in quadrant 3. You can see it's rad 3 over 2 and 1/2 are my two values, and because I know it's in quadrant 3, they're both negative. One thing you can notice on your circle is everything that's over 6, 5 pi over 6, 7 pi over 6, pi over 6, 11 pi over 6, all of those over 6's are 30-degree reference angles. So anything that's over 6 in our radian measures has the same coordinates as 30 degrees, except once you know what quadrant it's in, that changes your plus and minus signs. Because this is in quadrant 3, they're both negative. Also, you can do the same thing with the other radians. All the ones that are over 3 are our 60-degree reference angles. All the ones over 4 are our 45-degree reference angles. So again, if you know quadrant 1, you know all the points on this circle. You just have to remember what quadrant things are in to get those plus and minus signs. All right, so let's fill our point in. Negative rad 3 over 2 and negative 1/2. Okay, so I want first the sine of 7 pi over 6. Okay, to get the sine of 7 pi over 6, we know from the unit circle, that's our y value. So quick and easy, negative 1/2. Next, I want the cosine of 7 pi over 6. And we know from our unit circle, that's the x value. So that is negative rad 3 over 2. Next, I want the tangent of 7 pi over 6. Tangent is y over x on my unit circle. The y-coordinate is negative 1/2. The x-coordinate is negative rad 3 over 2. Now, when you have over 2 in both your numerator and denominator, that's pretty much saying 1/2 is a common factor of the numerator and denominator. So actually those 2's end up canceling, and also the negatives end up canceling. Leaves you with 1 over rad 3, and it's positive. And then if I rationalize that, remember we're multiplying top and bottom by rad 3, I get rad 3 over 3. Okay, my reciprocal functions now. Cosecant is the reciprocal of sine. Sine was negative 1/2, so cosecant is negative 2. Secant is the reciprocal of cosine. So if I flip it, negative 2 over rad 3, and then if I rationalize, negative 2 rad 3 over 3. And then finally, cotangent is the reciprocal of tangent. And I can work smarter, not harder here. I'm going to flip this guy that has the 1 over rad 3. So that's going to just leave me with rad 3 over 1, or just rad 3. And there you have all 6 trig functions. Most of the time when you're doing these, you won't have to find all 6. It'll just say 1, tell me the cosecant of 7 pi over 6 or the cotangent of 7 pi over 6. But this example gives you a nice picture of how really you could find any of them from that single point, as long as you know that point. All right, and there's again that definition of our coterminal angles. So let's talk about if we see something big like this, 1125. So that is definitely not on our unit circle. Our unit circle only goes up to 360. And you might need a calculator for some of this because these numbers might get a little big if you want to grab your calculator. All right, so we're going to take 1125. Because it's too big, we know that a full rotation is 360 degrees. That would give me a coterminal angle, and that would give me a value that is exactly the same as 1125 when I find its tangent. So if I subtract 360 from 1125, I get 765. That's still too big. I'm going to subtract 360 again. I get 405, still too big. I'm going to subtract 360 again. So I'm actually taking 1125 and I'm subtracting 360 3 times is where we're getting this number from. Okay, and you can add and subtract 360 as much as you want because it's just rotating a full turn. The point is not moving when I do this. So this is tangent 45. That's what that tells me. The tangent of 1125, that really big number, is the same as the tangent of 45. And 45 is on my unit circle. Well, we remember on our unit circle, tangent is y over x. If you look at 45 degrees on your circle, any 45-degree reference angle will have the rad 2 over 2's for the points. And because it's in quadrant 1, both of them are positive. Rad 2 over 2, rad 2 over 2. So what we have here is something divided by itself, and we get 1. Cosecant of 1860, again, way too big. All right, so I'm going to subtract 360 a few times. So 1860 minus 360 once, twice, 3 times, 4 times, 5 times. I think I have to do it here. Yep, if I subtract 360 5 times, I get 60 degrees. So this is the same as cosecant 60 degrees. All right, so cosecant is the reciprocal of sine. Sine is my y-coordinate. So I need to find the reciprocal of my y-coordinate at 60 degrees. So if you look back at your unit circle, 60 degrees That's our 60-degree reference angle. My y coordinate is rad 3 over 2. All we have to do is flip it, 2 over rad 3, and then we know we want to rationalize that, multiply the top and the bottom by rad 3 over 3. So I get 2 rad 3 over 3. 3 there, not a 7. Come on. All right. Secant of 7 pi. Let's see what happens if we've got a radian. If it's a radian, if it's too big, bigger than 2 pi, we're just going to subtract again a full rotation. And that's 2 pi. And I actually think these are easier because these are just more like fractions. You can do them easier in your head than with those big radian ones. If I subtract 2 pi once, I get 5 pi. If I subtract 2 pi again, I get 3 pi. If I subtract 2 pi again, I get 1 pi. That is on my unit circle, secant of pi. Secant is the reciprocal of cosine. Cosine is my x-coordinate. So what we're going to think about is what's my x-coordinate at pi. Now pi is one of the easy ones. Pi is just to the left 1 unit. So if I go left 1 unit on my quadrants, what's my x-coordinate going to be? My x-coordinate is going to be -1. So 1 divided by -1, the secant at pi is -1. Okay, one more here. Now I've got a negative angle and it's a radian. So negative is too small for my unit circle. So we're going to add 2 pi to that number. And remember, we can maybe think of that with a common denominator. Instead of 2 pi, let's think of it as 4 pi over 2. All right, so I have -3 pi over 2 plus 4 pi over 2, which would give me 1 pi over 2. On my unit circle, cosine is my x-coordinate, so that's what we're looking for now. What is the x-coordinate at pi over 2? Pi over 2 is just 1 unit up. It's 90 degrees. If I go 1 unit up, what's my x-coordinate? And that is 0. Make sure anytime you are asked for a unit circle value, you are always, always, always giving exact values. Decimals will never be accepted and are, in most cases, rounded here. So you want to make sure you're using those radicals and you're showing this work when necessary, especially on your homework. Math Excel, there's a lot of very small, quick problems, and it's super easy just to want to like Google those answers to kind of get through it. But truly, guys, you really need to practice these. These are the building blocks of what we're going to do all semester long. And if you can't pretty quickly find tangent 45 in your head, that is going to be a reoccurring theme that is going to make much longer and more involved problems very difficult, because something like tangent 45 should really truly be a 5-second question moving on past this week. Okay, I'll show you where we're going to have an opportunity to practice these too. All right, so that's as far as the lesson that we want to go. Your 5-3 Math Excel, I believe it's due Monday or Tuesday night. I don't have that in front of me. We'll look at the WAG in a second here. I'm not going to write it on there. And you do have a unit circle quiz on Tuesday. Also remember, guys, that you have, well, your 5-2 Math Excel actually was due last night, so you don't have to worry about that. So you can get started on 5-3 this weekend. All right, what I want to talk about for the last minute here is I just want to kind of give you some information about what this unit circle quiz is going to look like on Tuesday. And again, on Monday, all we're going to do in class is just practice with the unit circle. There is nothing new at all. Okay, so for the unit circle quiz on Tuesday, you will not be allowed to use any type of calculator. No red calculator, no graphing calculator. I will give you a piece of scratch paper, and that's it, a blank piece of paper. And then you will also have a blank circle given to you. When I say blank circle, I mean it's a circle with lines on it. That is it. Nothing else is filled out for you. We, as a class, for 30 minutes, will look at a slideshow, and every minute the slide is going to change. On each slide will be one of our trig functions, so one of the 6 ones, sine, cosine, tangent, cosine, cosecant, secant, cotangent, and then an angle that's either in degrees or radians. So it might say secant 7 pi over 6, or it might say cosine pi over 2, or it might say cotangent of 315. And your job is to evaluate that. You will not have time at the beginning to fill out the entire unit circle. Again, we'll talk about on Monday some tips and tricks with that, but you can fill it out as you go. I would recommend at least, bare minimum, you need to know at what point are all of your angles located, degrees and radians, and then at bare minimum, know those 3 points in quadrant 1 that we've talked about. And then from there, you can get any other point. And again, we'll talk about that more on Monday, some tips and tricks. So you're going to have 30 minutes, 1 minute per slide. You can always, as you have time, fill out more parts of the circle as you go. The circle itself will not be graded. I will never ask you guys to fill out a unit circle and grade it. The 30 questions where you are evaluating the trig functions will be graded, and they must be exact. If it's a sign error, if it's positive instead of negative, there's no partial credit. The whole problem's wrong. If you don't rationalize, the whole problem's wrong. So we want to make sure that we're being accurate with these, again, because it's so vital for the rest of this class. And it's going to be 1 point per problem, 30-point quiz on Tuesday. If you want to start looking over things this weekend, I did put a couple things in Polaris for you. Here's our WAG, and this video is linked on there now. Hopefully that's why you got here. Oh, there's our Math Excel deadline. It's the 23rd, so let's see, that is Tuesday night next week, I think is when that's due. Okay, so you can be working on that. If you scroll down to where it says class assignments and materials, you've got a blank unit circle like the one you got in class today if you want to practice filling that out. You have your circuit training, which is due on Monday. That's just right triangle stuff. Actually, is the 23rd Monday or Tuesday? Hold on. Today is the 20th. So, oh yeah, that's Monday night. Everything is due. Math Excel's due Monday night. Okay, and then the bottom 3 links here are your practice options. Okay, the first one, if you click on it, this is a set of links that'll take you to some Quizlets. Ignore that, I guess. See if I can open it this way. Hopefully, maybe. If not, I'll fix the link for you guys. And one of these, oh, there it goes. You can just click the little globe. One of these is degrees and one is radians. And this will just give you flashcards. Sine 30, cosecant 270. And one of them, again, is all degrees. The other is all radians. So you can practice that way. The second thing that I put in here for you is, I love this website. So this is called thatquiz.org is where you're going to go. So you're going to go to thatquiz.org. If you click here, it'll open the practice site. If it doesn't already take you to where it says trigonometry, click trigonometry. Then on the left side, you're going to change all the settings to match what you see in this little picture here, and then click start. And it will just throw at you an unlimited number of problems like what you're going to see on the quiz. The only thing that I want to caution you on this website is that it doesn't rationalize the answers. So instead of rad 2 over 2, that won't be an answer choice. It's going to be 1 over rad 2 instead. And you just have to know that, oh, if I rationalize 1 over rad 2, I get rad 2 over 2. So just be careful with that. And then the last link, you guys can print this if you want to. This is just a worksheet. The first 2 pages are practice problems, and the second 2 pages are all of the answers to the practice problems. Let's see if it's going to load here for you. There we go. Okay, so all of these at the top, there's some pictures, so you can start kind of visualizing it. And all the ones at the bottom, this is what your quiz is going to look like. And guys, there are going to be some that are not on the circle to start, where you're going to have to add or subtract a full rotation, either in degrees or radians. And we'll practice on Monday together, but there's opportunities to practice here as well. And then you can see if you scroll down, in red, there are all of the solutions that are rationalized too. So you've got 3 excellent options to practice with on your own. You can practice this weekend, you can practice Monday night, and then in class together on Monday, we'll talk about those special things you can notice about the circle, easy ways to remember where your angles are located, what the points are, and then we'll do at least in class on Monday 30 practice problems together, just kind of slowly working up to being able to do 30 on your own on Tuesday. Okay, so go ahead and get working now on your 5-3 Math Excel that's due on Monday night. You can work on your circuit training, and then Monday I'll be back with you guys and we'll practice some unit circle stuff together. Have a great weekend.